Welcome to Crosstalk Solutions. My name's Chris, and today we have a very exciting video for you. We are here in Los Angeles with Cambium Networks, and we're going to be setting up a point-to-multipoint network for the Community Broadband Project. Now, what is the Community Broadband Project? We're going to get to that in just a bit, but for now, stay tuned for a really fun video. Right in between you guys.
Oh boy. Oh goodness. All right, 3 guys on a bench.
Do we have any more bench space? Is this it?
I got.
You're off the side? Okay. Okay, so we're really excited to be out here in Marina del Rey right now. To my right is Brandon Yarbrough. Brandon is Crosstalk's wireless ISP point-to-point and point-to-multipoint expert. On my left here is David Barger, and David is our routing and networking specialist. So these two guys help me out tremendously. So I'm also very excited because I've never actually met Brandon in person before. This is the first time we're working together over 2 years, and we've never met Brandon. We don't work anywhere near each other. I'm out of Oregon. David is out of Pennsylvania, Brandon's out of Albuquerque, New Mexico, and so we do a lot of video calls and things like that, but it's very rare that we get to be here in person, and so we're really excited to be working on the Community Broadband Project, where we're going to be setting up a point-to-multipoint real-world example and doing some testing with some Cambium Networks gear. So I'm really looking forward to it, and yeah, what about you guys?
Yeah, it's been been great so far, and we look forward to what the project has to come.
Yeah, absolutely. So that's about it, and we're going to get right into the project. We're going to do some testing and climb up on top of a building. What do you think?
Sounds like a plan.
All right, let's get going. Okay, so I'm here with Josh Shapiro. He is the CEO and founder of the Community Broadband Project. And I originally heard about you guys from a Vice Motherboard article that was posted online, and I was really intrigued by what you're doing. So tell me and tell the audience about the Community Broadband Project.
Great. So we were just started about 8 or 10 months ago, doing some research and just digging around and seeing if there was a way as a small team of tech-minded folks and creatives to create a better kind of internet for Los Angeles. And then also addressing the net neutrality issue and customer privacy, being able to, as a user, opt out of my information being shared and browsing habits and all that, as well as all of the implications behind what the future net neutrality and sort of those things have in play. So the beginnings of it were trying to see if it was possible to start a small-scale ISP, something more community-driven, with at first being self-funded and just bringing in talent where we can. Sure. And then as it started to become more and more realized, I pulled together a group of talented individuals that could kind of form that team, and then ultimately we found someone that would fund the project.
Tell me about the ramp-up process. How is it? What kind of learning curve? What kind of struggle has it been to get going?
Right. So, so my background is when it comes to this, aside from some sysadmin work in the past, I guess you could just say I'm a tech guy and a tech hobbyist. Playing with computer hardware and some networking hardware and that kind of stuff. Sure. And so this was it was new and exciting and all of the possibilities and yada yada, but it really started at base level, starting to figure out like what is RF and how does it work and what are the do's and don'ts, right. And starting to get a grasp of the catalog of equipment out there that you have to sort of intermix to create a functional wireless ISP.
There's a lot. I mean, that's something that we get a lot of questions about, is what antenna should I use for this? What antenna should I use for that? And that's its own learning curve, is just figuring out not only what equipment is out there, but even within a particular, brand, what does each different antenna do, what's it good for, and what's going to work in your specific environment.
Right, and then one step beyond that is sort of the business aspect, is what are the different price points those are at, and where do they sort of fit into your business model. Because at the end of the day, you're running a business,
right? And
it has to. You can't just pick the best of everything for every case. Sometimes you're looking at what is the best option for the value, or what works well enough, and then mixes well with the other equipment, or plays nice with the rest of the equipment you have. So,
how much importance are you putting on scalability for future growth?
I would say a high importance on that, given that. We are in a massive city and with very high density and some challenging interference issues. So I would say not just scalability, but also being able to, from a training standpoint, being able to quickly train community members that may not have years of technology in their belt, but will need to interface with the equipment and be able to operate and install it to some degree.
Yeah. If someone in the audience was, interested in kind of doing what you're doing, starting a small-scale wireless ISP or even a large-scale wireless ISP, what would be your best advice, sort of having dove head first into it already?
Yeah, I would say my best advice would be to make friends quickly with other people that are more experienced than you are. Lots of networking. Yeah. Everyone has been so friendly and helpful. Anytime we call someone up and or pop someone an email and say like, hey, this is what we're doing. You guys are doing the same thing, or like a couple years ahead of us, or you have a huge network of 20,000 users or whatever. When we started to ask them stuff, they've been very open, and that's been the sort of the primary learning method so far.
Very cool. Well, what's the future of the project, and where do you want to see it go?
Yeah. Well, achieving sustainability would be a great first step. Right now we're in our beta phase, so we're funded and testing some equipment to see sort of what works best for our situation out here in Los Angeles and in sort of our specific network, since really every region is different, and those regions have sort of sub areas that have different challenges. So once we sort of start to figure out what our hardware situation is, we'll have a stronger grasp on those models and sort of how they plot out. But our larger vision is being able to serve the grander Los Angeles area, and providing people with an option for internet service that's fast, net neutral, more affordable, and especially for the communities that are currently underserved and trapped on DSL speeds. Ultimately providing them with more access.
Yeah. Cool. Well, thank you for giving us the opportunity to take a look at what you're doing here, and I'm excited to do some testing and get up on the tower and hook up some equipment.
Yeah, let's do it.
All right, cool. Spent a few hours planning out where we wanted to position our ePMP 2000s and what kind of tests we wanted to run to the ground with the subscriber antennas. Now I have to give a big thank you to Cambium Networks for sponsoring the equipment that's being used in this video. Everything that you see today was donated by Cambium Networks to the Community Broadband Project. They also sent out Chris Catania, who is an expert in all things Cambium. So we unboxed all the gear and then configured everything based on the point-to-multipoint design that we came up with using Cambium's Link Planner tool. We first input all of our access points and subscriber antennas into this tool and then position them where we wanted our coverage. We decided to place one of the ePMP 2000 90-degree sectors pointing out towards the Santa Monica and Venice Beach area. The second sector is pointing more northeast towards the Mar Vista and Century City area. For each access point, we set the range that we wanted to cover, the antenna height, as well as the azimuth. Now, the azimuth is basically what direction the sector is pointing. From there, we could play around with the antenna tilt or any other settings that we wanted to in order to find the best configuration that we could on paper. Now if you look at our subscriber antennas for this first access point, notice that 2 of them are black and 1 is red. That's going to come into play shortly. But before we take a closer look at all of our point to multi-point links, let's first take a quick look at the equipment that we're going to use. Okay, so we've got all the equipment laid out on the table that we're going to use, and Josh, how are we going to be using this first and foremost?
So we're going to be pushing a backhaul link to our main tower, where we'll be using this as a point to multi-point system to throw start with a 90-degree sector up and see sort of how clients are connecting to it, what kind of speeds we're getting off these, given our noise and interference in the area, and just kind of see how it works.
How do you plot out, like where the 90 degrees is going to shoot out over a given area?
That's a good question. So we usually start with mapping our environments out on our network, looking at subscriber density and sort of how many subscribers we have in any given area and what kind of RF challenges we're facing in that area. And then from there, we'll go back to the table and start to look at what kind of equipment we have available to us and how it best fits in those environments.
Very cool. And so today we're going to be using Cambium ePMP 2000 stack with some subscriber antennas. What are we looking at here, Chris?
So specifically hardware-wise, what we have here is our ePMP 2000 with a dynamic RF filter. We have a 90 or 120 degree sector antenna.
Now explain that, because I covered that in the video that I did on this, but basically your full bandwidth to 90 degrees, and you can kind of go a little bit further to 120, but you're not necessarily going to get full performance?
Correct. Yeah. So typically with antennas, a 90 degree antenna is actually a 60 degree antenna with 3 dB of roll-off. So that is borderline what this sector antenna is. When you want to use it for 120 degrees, you have to take into account an additional 3 dB of roll-off, but you're able to do so. Just be aware your distances with that extra side skirts will be severely limited.
Yeah. So if I had 2 of these sectors and I wanted to cover a little bit more than 180 degrees, would I be aiming them exactly 90 degrees apart, or could I aim them a little further out, have a little bit of overlap in that like extra arc?
Yeah, you can aim them slightly further apart. It unfortunately with wireless, it's a field of variables, so you really have to be on site and kind of play with it. But just take into account that when you separate them further and you want to use them for a little bit broader coverage, where they will overlap, the power level to each individual AP is going to be less.
So that's the sector, and then on the back here, of course, we have the access point. And what's this getting?
That is our ePMP 2000. That's our access point with GPS sync and a dynamic RF filter. And we also paired this setup today with our smart beamforming antenna. This is optional, but it provides better coverage, better interference mitigation.
Yeah, and this is the one that I explained in my Cambium video. I'll put a link to that somewhere. But basically, this is an array of additional antennas inside here. Tell me if I'm saying anything incorrectly. That when a client connects to the sector antenna, it then passes the signal. It basically triangulates their horizontal and vertical, and then passes them to the smart antenna for a more targeted beam to a specific, subscriber antenna, right?
Correct. So
I could be a Cambium sales engineer.
Absolutely. You want a job? The smart antenna is an array of something along the lines of 45 different antenna patterns. And essentially what happens is if the AP determines that you'll have a better connection going through a more direct beam, it will use the uplink for the smart antenna. But if you need the higher gain for a better connection, it'll use the usual sector. AP determines this automatically on its own. There's no user intervention here. And if you go into the actual settings on the AP under Monitor Wireless, it tells you on a per subscriber basis whether that subscriber is using the smart antenna or the sector.
Now from a sort of like a cost upgrade standpoint, is this a system where we can start with a sector and then over time upgrade specific sectors with this antenna as well?
So I frequently guide operators to always have at least one smart antenna on the shelf. It shines with high interference in that same sector. So when it steers a beam, let's just say to the left of the sector, if there's some intermittent noise on the right-hand side of the sector, you're providing additional isolation. Interference always hurts the client-side communication the worst. So to be able to focus a beam create additional isolation from that interference, boosts your SNR, and also increases your modulation rate. So what I tell operators is always have it on the shelf. If you're deploying and you notice that there's some interference and you're running into problems, try hooking up the smart antenna to that sector and see if that improves the performance. If it does, buy another one, keep that on the shelf for the next AP. If not, take it down and save it for a situation where you need it.
What kind of subscriber density are we talking about here? And as far as subscriber count and maybe its range, or
Yeah. So ePMP has a hard limit of 120 subscribers. Most operators aren't adding that many clients per sector. It's a fairly loaded question with wireless. I always like to say it's not really about the subscriber count, but the packages you're offering.
Right.
And then also your customer makeup comes into play, where if you're selling 10 meg circuits, and if I sold you a 10 meg circuit and you are always using that 10 meg circuit, that hurts a lot more than if I sold Chris a 10 meg circuit and he only intermittently uses it. Because essentially when I look at oversubscribing on my APs, I would have to factor your 10 meg circuit out at straight throughput and then oversubscribe for Chris.
Right, exactly.
Typically, if you want to offer a 25 meg plan, anywhere between 10 and 20 subscribers per access point, depending on the customer makeup. I've seen as high as 30, 40 customers selling those higher plans per access point.
Great, okay.
What are we talking about as far as subscriber antennas here?
So we have two different subscribers on the table here. We have our Force 180 flat panel 16 dBi subscriber module, and then we have our Force 200, which is addition feed horn style 23 dBi subscriber.
So where would you use one versus the other?
For shorter shots, operators tend to use Force 180. Typically, for shorter shots, customers tend to use Force 180s. When they need the additional gain on the subscriber side, they would move up to the Force 200. Also, usually when an operator is a certain size, they'd rather just standardize on one type of CPU hardware, and a lot of operators just standardize on the Force 200.
Sure. And what is the price point for all of this?
Got it. So if we talk MSRP pricing, we have our Force 180, which lists for $99. Our Force 200 in 5 gig lists for $129. We do have optional radomes available for $19. ePMP 2000, that lists for $599. The sector antenna is $219, and the beamforming antenna is $399.
Once all of our information has been input into Link Planner and we're happy with the configuration that we came up with, we can then click on the Google Earth button, which automatically maps everything that you input directly into Google Earth. So from above, you can see the entire point-to-multipoint architecture as well as the coverage areas that we're planning on covering. The Community Broadband Project has an agreement with a 17-story apartment complex in Marina del Rey to use their roof as a tower location. So that's where we're going to be placing our ePMP 2000 sector antennas, actually right up on top of this section right here where this pin is. Not only can they remotely control all of the equipment they have on this tower, but they also use it for their internet backhaul. In addition, all of their subscribers do radius authentication from this tower over a secondary wireless point-to-point link that goes to the servers at the WeTransfer office. They also use it for testing all sorts of different equipment. These guys are making full use of the tower space that they're renting. Now from this tower, we're going to run 3 different subscriber tests. The first subscriber is on top of a 6-story parking structure in Santa Monica. Now for each of these locations, we're going to be setting up one of our subscriber antennas and then measuring to see what kind of signal strength and internet speeds we get in each location. Our next location is the very end of the Santa Monica Pier. From here we should have pretty good line of sight to the ePMP 2000 access point, and this location is the furthest west that we would expect our signal to reach. Our final subscriber test is at the WeTransfer office. Now this location has very clear line of sight to the tower location, so we shouldn't have any trouble getting a signal here. Okay, so with everything planned out, the next step is to head over to the apartment complex in Marina del Rey and install our access points. And that's where we were headed off next to prepare to go up onto the roof.
we've got two of the Cambium Smart Sector antennas set up. One of them is pointing off to the east here, kind of the Century City area, and we've got the other one pointing sort of toward the ocean, a little bit up Venice in that area. Our idea is that they each have about a 120-degree arc, and we're crossing them over just a hair so we don't waste the sort of the main lobe right over the ocean. So.
Yeah, we don't want to run it into the ocean.
Right, right. So one's kind of going up the water, and then the other is kind of a little more inland.
And what's one of the biggest problems that you're seeing when you're down on the ground now and trying to connect up to these antennas up on top? What are your obstacles?
Great. So in Los Angeles, we've got it's primarily 1- and 2-story homes and multifamily dwellings, and so it's not too bad connecting to them, especially all the flat roofs start making it pretty easy when you're closer. But the further you get, actually palm trees become a problem, and they're pretty springy. They swing in the wind, so one day you might have a great link, and then you come back, and when it's windy and you're looking at the fire rates and they're bouncing around, and sure enough, you've got a palm that's a few hundred feet away or 1,000 feet away that's dancing in the wind, and so it's kind of been an interesting LA-specific obstacle we come across.
Palm trees.
Yeah. Yeah, so this is another test we have set up. Right now, this is our entire stack, but you notice not all of it is connected right now. We've got some radios that are kind of waiting to be connected, and what we're doing is we're using this as a test rig. So we've got a lot of stuff that's kind of aimed in certain directions, and we've got CPs on the other end and other stuff on the other end, and we are powering and hooking up some of it at a time, test it and see what that scenario looks like, and then powering it down, powering some other stuff off. Just kind of saves us the time of having to come up here every time we want to swap a piece of equipment, and gives us kind of a interesting, variety of different equipment.
Now, would you recommend to someone coming into WISP to test out different equipment before they get started? I mean,
yeah, absolutely. There's so much equipment on market, and there's a lot of variety, and it really you really need the right tool for the job, and your environment is going to change. In our case, it's almost neighborhood to neighborhood. We've got, you might have one neighborhood with a lot of interference, another might be, spread out single family homes, and then you move to the next and it's extremely dense. And so what we're doing here is we're seeing what works best for those scenarios, so we have a clear understanding of in the future what we will approach a given scenario with.
all right, so we're currently at a parking structure in Santa Monica. We're very close to the Santa Monica Pier. We're on the top level of the parking structure, and we're doing our first subscriber antenna test. You can see they're setting it up right behind me here. And it's gonna be pointing over that direction. So that is a Cambium Networks Force 180 on top of this pole right here. And we're looking to go to the tower, which is about approximately this direction, about 3.5 miles away from us. So we're gonna set that up and then see if we can get a signal, and then run some speed tests if we can. So we were able to get a signal on both the Force 180 and the Force 200, but the signal was not great, and it also ended up going up and down, and we feel like either some trees or a building is in the way of our line of sight here. We're generally trying to go that direction, so we're thinking that it might be this white building or some of these trees are sort of blocking the signal. So we're going to move on down instead to the Santa Monica Pier and see if that works better. And hopefully they don't, give us any crap for testing this stuff out in such a public area, but we'll see. All right, we're moving down to the pier next. Okay, so we're now here at the very end of the Santa Monica Pier. You can see the Ferris wheel behind me, and we have successfully connected, according to the Cambium Networks interface, we are 3.54 miles away from the access point at this location. And we did a speed test. We got about 25 megabits down and about 9 megabits up. And it's actually very, if you look at the graph of on Google Earth, and we are just skimming the side of one of these large white buildings over there. I'll see if I can get a shot of it. We're just skimming the side of that building right there, and the top of the tower is just beyond that, 3.54 miles away.
Okay, we're in the home page of the subscriber module.
This is the
Force 200. We are connected about 3 miles out from the access point. We just barely have line of sight here. On the home page, you can really easily see the channel bandwidth. So we're using a 40 megahertz wide channel on 5195. Session uptime, link quality, capacity, and then wireless status are all things that I look at right away just to determine if the link is up and running.
right.
So under monitor performance, you're able to get Ethernet and wireless statistics, which can help troubleshoot links that are dropping packets due to capacity drops. So as you can see, we're not dropping any capacity packets.
That's good.
Correct. So that means the AP is not overloaded. Error packets as well. Just know you will see some error packets. We haven't been pushing.
The nature of the wireless.
Correct.
Yeah.
That's just what it is. Also, we haven't been pushing traffic to this link, so these results might be a little skewed. We've only just been running some link tests. Monitor wireless. So this tab is probably one of the go-to tabs for most operators that use Cambium. We're in the subscriber module right now, so it shows link distance. It shows transmitter output power. The throughput chart on ePMP is a great tool. So if you have a customer that complains about, oh, you know, I'm not getting my full speed, you can go to the throughput chart in their subscriber module and see what speed they're getting over time, and you could actually change the access from seconds to minutes to hours to get more of a historical database of over time. Yes, you know, I see that you are running slightly below the speed that you do pay for, or over time, you know, your throughput is in line with what you're paying for.
Yeah.
So under tools, wireless link test. Let's start a link test right now.
Okay.
So we are doing a link test from the subscriber module to the access point.
Now the packet size, we did the link test earlier on 800. This is now at 1500 bytes. I mean, does that make a difference in the speed test results?
Yes, it actually makes a huge difference. So over this wireless link test in ePMP, this is basically the over-the-air rate. We can run this test again with a 800 byte packet. So
yeah.
This link test shows UDP traffic over 1500 bytes. Let's do UDP traffic over 800 bytes.
And so at 1500 bytes, we just got a 74 by 10.
Mm-hmm.
That's pretty good.
It is pretty good. And over an 800 byte packet size, we're still getting about 71 down and 8 up. In the access point, it shows you a lot of the same settings on the home page with the added caveat of sync status.
So now this is remotely connected to the access point. Now we're connecting through the wireless link right now to the access point?
Correct. So I am directly plugged into the Force 200, and I am in the settings of the ePMP 2000 access point with our Cambium Networks 9120 degree sector. That's about 3 miles away. Also, you can see that we are using a smart antenna here.
Oh, the smart antenna is working.
Yep, it says the smart antenna is connected and powered on.
And then if you go back to the dashboard, right, that's where you can see our horizontal and vertical.
Correct, yeah, under that monitor wireless tab.
Yeah.
You can see that this
we're
access
actually
point
still on the sector right
is
now.
still using the sector, correct.
Okay, and then once, if it can, it'll pass it off to the smart antenna, and then you get a more directed beam at our client.
The AP automatically determines which antenna is best to listen to the subscriber from. It's essentially just a calculation based off of the total throughput it thinks or it has gotten from the sector antenna versus what it thinks or it has gotten in the past from the beamforming antenna.
Yeah.
The nice part about doing a link test from the access point is you select the SM you want based on its MAC address.
SM being subscriber module.
Correct, subscriber module. And we could set these settings the exact same, and it actually has the monitor, the tab for the SM down here. One thing to note, the downlink capacity and downlink quality, again, are very dependent on the total number of traffic that's been passed. So as we start this test, you'll see these numbers along with the MCS rate change probably drastically. So as you can see, we jumped up to a 60% downlink capacity because now we're passing traffic through the link.
Sure. 72 by 9.7.
Mm-hmm.
That's beautiful.
And then let's go to fast.com and speed test and do a true TCP IP test.
All right. And this is essentially a test of what we would expect if we were the subscriber. We could expect about 29 megabits from this distance, this line of sight, these settings, etc.
Correct, yeah. So essentially fast is testing your connection to Netflix. So you'll have a 30 meg connection to Netflix. And when we test and speed test, it'll actually give you a latency. So we have a ping of 24 milliseconds, which is pretty good.
All right, 46, that's great. All right, 46.49 by 8.46.
Correct. So in a 20 megahertz wide channel at about 3 miles out, you could pull about 50 down, 10 up subscription plan. So we've added all these devices to CN Maestro. And
CN Maestro is the cloud hosted. So we were looking at the local interfaces of the subscriber and the access point, and now we're looking at the cloud controller, so to speak.
Yep, this is correct. So under monitor your network, as you can see, our tower's red. That's because we have 2 APs that are registered,
One of them's not working. One of them's not on right now.
Correct. We powered this one off. So it will highlight your tower red if there's a problem with something in your at that
under
tower.
the tower. Yeah,
correct.
Gotcha.
We are in the access point in CN Maestro. It gives you stats like the MAC address, the serial number, frequency, channel bandwidth, download upload ratio. That's also important. We are running this in a 75 down, 25 up frame utilization. You have to specify what portion of the frame you want the AP to talk to the subscribers, and what portion of the frame you want the subscribers to be talking to the access point. Typically, WISPs will install with a 75 down, 25 up with Cambium equipment, just because they sell internet plans, and more often than not, they want to favor the download speed.
Sure.
The software update tab, if you wanted to update the software image on the devices in your network, you're able to do that actually all in one shot. So it can actually do SMs first and then the access point, or the AP first then the SMs. So I could select this, and it automatically selects these SMs, and I could change it to any of the listed firmware here. So 3.5.1 is what's recommended now. 3.5.2 is in beta, but it still allows you to go all the way back to 3.4.1.
Wow.
So there's no real rush to upgrade everything until you're ready and you feel confident.
I mean, I know with other products I've worked with, it's a smarter idea to upgrade the far side first before you upgrade the near side. Is that kind of the same here?
I would probably say the best practice is, yes, to upgrade the subscriber modules first and then the access point. You could also do a remote link test as well, which is really nice.
Let's run one.
Let's do it.
So this is a remote link test from the access point to the subscriber.
Correct.
Using the cloud-hosted CN Maestro.
Correct.
53 by 8.3. Oh, 63 by 8.3.
Yeah.
Very cool. Well, cool. I mean, successful test. Are you pleased with the results that we're seeing at this distance and these speeds? And
yeah, absolutely.
Very cool.
Okay, so now we're going to try a shorter range test. So our last test was from the Santa Monica Pier. It was just over 3 miles range. In this case, we're doing a much shorter throw, which is going to be more realistically what they're going to expect for this project. You know, an antenna up on the roof and then a shorter distance throw. I mean, up to 3 miles would be about the maximum length they'd be doing. They can get plenty of subscribers in that 3 mile area. So we've got the Force 200 again set up on the pole right here, and we're actually going to be shooting up to the tower, which is where we were yesterday, which is right up here. So you can see this is the WeTransfer building, this white building, and then right at the very top of there, you can just get a glimpse of the tower where we were yesterday. So I think that's about a half-mile throw, and Brandon and Josh are setting that up now. All right, so what are you seeing with the short link test?
Great, so we're using the Force 200 dish, and we're only running about, it's about 0.3, 0.4 miles, and we are maxing out the radio at about 65-ish megabit per second down, and about half that up or so. So I'd say it's a pretty solid link. We're at negative 50 dBm. It's about as good as it's going to get.
All right, so we did our short throw test. We finished that. We did our long throw test out to the Santa Monica Pier. Both tests were successful. We got, I think, pretty good speeds on both of those tests. So what do you think? What do you think of the Cambium equipment? What do you think of the testing that we were able to pull off?
Well, I think it's pretty awesome to be able to get a huge sector that covers a ton of range and gives you pretty damn decent speeds with the number of clients that can connect to something like that. So I think we'll have to do some more testing and kind of look at how many clients we can pack on and what the numbers kind of look like. But so far, it's been great.
Yeah. Now, I mean, our test out to the Santa Monica Pier was about 3 miles. Is that about as far as you would expect to be going in this dense an area with, you know, the place where we have the access point?
I would call that, in our case, probably worst case scenario, going that distance. And in that case, a lot of our Fresnel zone was getting cut off, and we were going through, you know, a couple trees and stuff. So sure. I was surprised the speeds we were able to get given all of that. Right. But testing it kind of shorter range in probably more common case, it was great. It connected right away, super easy to use. Mm-hmm. I'm very excited to be able to take a look at some Cambium stuff more seriously.
Now, you guys aren't live yet, you know, officially, right? You've got some test clients out there, but how much, I mean, if someone was looking to start up a wireless ISP, how much testing have you guys done in preparation for, you know, possibly going live in the near future?
Right. Well, right now it's been about, I would say 2 to 3 months of on-the-ground testing with, you know, hardware in hand, everything hooked up, things rolling. But there was something about 8 months of prep time leading up to that. So a lot of learning, a lot of you know, understanding the equipment out there, and, you know, finding our tower site provider, sure, working through leases, legal structure, lots of business stuff.
Right.
So I'd say you know, while you have to consider the technology aspect, there's a whole slew of, you know, business aspect to be able to set this up, you know, properly and build it so it can scale and grow quickly. And
on top of all that, you had to build a team of you know, like-minded individuals to help out with the project. How did you go about finding the people that are on the team?
Well, in a place like LA, we're so fortunate that there are so many people that are like-minded and interested in a project like this. So I early on jumped on Reddit and Nextdoor and pulled in neighbors and interested people, and sort of over the course of time, we distilled those people down to our core team of 6 that has professional expertise in sort of all aspects of running an ISP, you know, down to marketing and even, you know, the business and financial aspects.
Now, in a perfect world, when would you ideally like to start bringing live clients, like out of beta and actually on your system? When do you expect that to happen?
Yeah, so we've got about 2 months left planned in our beta before we go live. And we hope to have we're growing organically to start with, so we should have something about 50 or 60 clients on net. I think we already have about 50 signups. So
oh wow! So people that have signed up, but they're just waiting on a waiting list.
Waiting on an install. So we'll easily hit those numbers by then, maybe even higher.
Sure.
And then should be able to jump in head first if all goes well.
Very cool. So if people want to find out more about you or the project, where can they reach you?
Right. So check us out at communitybroadband.la. You can take a look at our website, see a little bit about us, and learn about our mission, and also check out our newsletter. We post newsletters every other week to give a status update on how the network is going and how we're growing.
Yeah, and also a special thanks to WeTransfer. We're actually at their office right now. WeTransfer provided some funding in order for the Community Broadband Project to, you know, take their time and do this kind of thorough testing to get off the ground before you officially launch. So thank you to WeTransfer as well. All right, cool. Well, I think that about does it for this. I'd call it a successful test, and thanks for giving us the opportunity to come down here and help you out and film it along the way.
Yeah, absolutely. Thank you so much, Chris.
All right, absolutely. Thanks. All right, guys. Well, that's going to do it for the Community Broadband Project video. I hope you guys enjoyed this one. And make sure you click that subscribe button if you want to see more real-world examples, real-world setups. We might even, you know, revisit Community Broadband Project in a little while and see how everything's going. So if you like this video, please give me a thumbs up. And if you'd like to see more videos like this, please click subscribe. My name's Chris with Crosstalk Solutions, along with Josh with Community Broadband Project. Thank you guys so much for watching.